All right, so let's talk about translations and reflections of functions. So this section is how do if you add a constant to a function, if you're multiplying, if you multiply by a constant, anything like this, if you throw a negative in there, any of these things, what does that do to the graph of the function? And so a lot of this, as you can see on this first screen, is going to be it's kind of a lot of rules. So if you remember the rules, then this is pretty easy. If you don't remember the rules, you can actually figure a lot of this stuff out on the fly. It's not super hard. You kind of need to know what to do. So maybe I'll show you on one of these first couple exactly how we do that. So we're going to let f as any function, and h and k are just going to be positive constants. So in this first one, we start with y equals f of x. So that's just a basic function. And this could be anything. So the rules apply no matter what type of function you have. You could have y equals x squared, y equals x cubed, y equals x to whatever exponent. You could have y equals 2 to the x. We're going to get into exponential functions in one of the next sections that we get to. You could also have a square root function. You could have an absolute value function. So it doesn't matter what the function is. If you're doing whatever this is, to the function is going to have the same effect. So in this first one, we're going to add a constant to the function. So what that does is it shifts whatever this number is. So if it's x squared plus 2 or x squared plus 3 or 4 or whatever number you want, it's going to move it up that many units. And so you can kind of see this. The way to test this, if you're in a test and you forget what plus k does or what minus k does, or if we do a minus h in the parentheses or whatever, if you forget what that is, you can make a little table. And well, let's use x squared, and then we'll do x squared plus 3. And so you just make a little table and pick a few values. You don't have to do many. You can kind of see the pattern pretty quickly. So f of 0, if f of x is x squared, f of 0 would be 0. If f is x squared plus 3, now we have 0 squared plus 3, so that gives us a 3. If we have x is 1, f of 1, when f is x squared, 1 squared is 1. If we plug in 1 to this one, 1 squared plus 3 is going to be 4. And then if x is 2, 2 squared is 4. 4 squared plus 3 is 7. And you can see going from here to here, we're just adding 3, which of course is what's going on. Now let's plot these ordered pairs and see what happens. So we have this ordered pair is 0, 0. So we'll plot 0, 0. And of course, maybe we don't even need to do that, but we know what the graph of y equals x squared looks like. So there's our x squared. Now if we want to do x squared plus 3, so now instead of 0, 0, we have the ordered pair 0, 3. Instead of the ordered pair 1, 1, we have the ordered pair 1, 4. So now 1, and then we go up 4. And then we have, instead of 2, 4, we have 2, 7. So now that'll be up here. And then you could also do some negatives if you want, and that's going to look like that. And so then we look at the graph, and that's what it looks like. And so you can see it's just shifted up. And this picture here, so this is more of this would be a different polynomial. Again, it doesn't matter. You can combine these as well, and it adding a plus 3 or whatever is going to do the same thing. It's going to shift it up. And so you can see this ordered pair here at the origin now is moving to there. And this ordered pair here is moving up to there. And so you can see there's not a scale on here, but they're showing you that we're moving up by k. So, so anytime you have a plus k after the function, whatever that is, you're shifting that original function up by that many. Likewise, if you subtract k, that's going to shift it down. So you can see that's the picture here. We shift it down. Now this one, this is different. So here we have x minus h. This is in the parentheses. So now you're changing the input. Here you're changing the output. And of course the output will change when you change the input. But here we're changing the input to affect the output. Here we're not changing the input. The f of x is still the same, but here we have an f of x minus 8. So when the input is being changed, when you're inside the parentheses of that f of x, now you're going to move right or left. And it's actually the opposite of what you might think. So here with the vertical shifts, the plus k or the minus k, the plus k, it makes sense, so we're going to move up. The minus k, it makes sense, we're going to move down. But now we have an x minus h or an x plus h. The minus h actually moves right. You might think because when you have the xy coordinate system, going this way is negative, going this way is positive, right? So you might think the minus h would move it this way, but it's actually the opposite. So now you're going to have the same y value. You have to compensate. And so we're going to move, it moves it right. And then likewise, the x plus h is going to move that left. So you can see the effect here. So f of x minus h, we move it to the right. F of x plus h, we move it to the left. So just keep that in mind. The vertical shifts are probably the way you would expect. The horizontal shifts are probably the opposite of the way that you would expect. Then we have what's called reflections. So this is going to be reflections. Up here we have shifts. So those are moving left to right, up or down. Now we have reflections. So y equals negative f of x is the graph of y equals f of x reflected vertically across the x-axis or turned upside down. So again, you could do a little table here. So if we'll just do negative 1, 0, 1 for the x's, x squared, that would be 1, 0, 1. Negative x squared, now whatever this is, just make it negative. So it's taking all of these y values. So these are going to be y values. And instead of 1, it's going to be negative 1. Instead of 1, negative 1. X squared. So, of course, we're not going to have any negative values over here. And then all of these are going to be negative. And so what that looks like, instead of the graph of x squared that looks like that, we have negative x squared that looks like that. And so we're just flipped over the x-axis. Now, if you put this inside, now we have it is going to be reflected horizontally across the y-axis. And so we won't use x squared because if you reflect that, it just looks the same. But let's do x cubed. So y equals x cubed. Y equals negative x cubed. That's what that would look like. And so we have x, and so let's just do negative 1, 0, and 1 again. So negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed is 1. And then now we have negative 1 in parentheses cubed, which it actually doesn't matter. We have negative 1, and then 0, and then 1 cubed would be 1. So actually, that's kind of a bad example because it's actually the same. But or no, it's not the same. Negative, yeah, this would be positive 1. That's right. Positive 1, because we have negative 1. So that'd be positive 1 cubed. Okay, so that was my mistake. Negative 1. And then plug in 1 for the x here, so that's negative 1 cubed. Which, okay, so that was my mistake. So we do have these flipped. So here is this graph. Y equals negative x cubed. This one, y equals x cubed, is going to look like that. Now, part of this, obviously, if you plot these, it looks linear, but part of this, you kind of need to know the basic shapes of these graphs too. That also helps. But it's not necessary. You can see that the y coordinates are changing signs, and you could keep going. You could plug in 2 cubed would be 8, and then you get negative 2 cubed, that'd be negative 8. So you can see that the y coordinates are just changing regardless of what the graph looks like. Okay. So here we have, so taking the original graph that is up there, if you have negative f of x, we just flip it upside down. If you have f of negative x, we're turning it around the y-axis. So that's a horizontal reflection. All right, let's see what else we have. So now let's look at an example. And so this is going to combine a couple. And so the order that you're doing these reflections actually matters. So in this case, you want to do the horizontal first, and then you want to do the vertical. And it may not matter in this case. You could probably do it in either order, but generally speaking, you want to do the vertical translation last. That's typically the especially if you have these reflections. And you could test this if you see an example. If you do the vertical shift first, you don't get the same graph as if you do the vertical shift second. So, but in this case, you do. But that's not always the case. So, general rule to remember: do the vertical shift last, and you'll usually be safe. So, the square root of x minus 1. First of all, the square root graph looks like that. Again, important to know. So, and I guess we should do both of these. So we'll try to make this a little bit accurate. So, we could do a table here. Square root of x. So we have 0. Square root of 0 is 0. X is 1. Square root of 1 is 1. We'll skip up to 4, and then we get square root of 4 is 2. So there, and then 9 square root would be 3. So this is going to look something like this, and go on from there. So now what are we doing? We are moving, so remember this is opposite, so you might think negative goes this way, negative actually goes that way. So we're going to move right 1, and then the plus 2 is going to move us up 2. So now this 0, 0 coordinate is going to move right 1 and up 2. This 1, 1 is going to move right 1 up 2. This one is going to move right 1 up 2, and then move right 1 up 2. And so we don't have anything, so don't continue this because we don't have anything beyond or to the left of 0, 0. So we're not going to have anything to the left of 1, 2. So don't just assume it continues. It's going to do the same as the original graph that we have. So there's that. And so notice all we did, you can find some ordered pairs. And so when you find this ordered pair, just do the shift. So we're going to move right 1 up 2, get this ordered pair, right 1 up 2, and so on. And that's all you got to do for these. And probably on my math lab, these are multiple choice. So you can, as you see the shift, you might have other choices. They're not going to have anything that's similar to this. They're going to have something that moves it, left 1 and up 2, or left 1 and down 2, or maybe flip upside down, do all kinds of stuff. But they're not going to have anything that looks close to that. So as long as you see the one that has the original graph moved right and up, probably it'll be the right one. All right, let's see what else we got. So here's another one. So, and this is still going with the square root of x. So now the negative square root of x, that is reflected upside down or over the x-axis. So now, so 0, 0 is not going to change, but now instead of 1, 1, that's going to go to 1, negative 1. So the x-coordinate is going to be the same for this one that's reflected. The y-coordinate is going to switch signs. So instead of the y-coordinate being 1, the y-coordinate is going to be negative 1. Instead of the y-coordinate, we had 4, 2. We're going to have 4, negative 2. Instead of 9, 3, we're going to have 9, negative 3. So that will look like that. If I could draw it, connect dots, and look something like that. So there's our C graph. C graph. Then, now what about this one? So now we're going to do the horizontal first. So horizontal, that'll be left 2, left 2, and then we'll do the reflection, and then we'll do the vertical shift. So we're going to go right 2, and I might do this one. I didn't give myself room, but I might do this one in steps. So start with the original square root of x. Now move left 2, and just kind of do this. Just kind of very, very sketchy. Not sketchy, that doesn't sound good, but you know what I mean. Just kind of sketchy, approximation, I guess, better word. So left 2, then reflect. So now reflect this one. So now it's going to come down like that. So reflect. Now shift it down 2. So down, or down 1. I should say down 1 for that one. So now just move this down 1. And so start like right there. So we moved left 2. So now we're at -2, 0. And then we're going to move down 1. So now we're at -2, -1. So we've essentially moved left 2, down 1 from the original. And so that will look, we'll kind of do this. We won't get this super accurate, but it'll look something like that. So something like that. So that's our D graph. And so this is kind of, when you have multiple of these, this is kind of how I would do it. I would do them in order and just do one step at a time. Don't try to do all of these at the same time, because it's a little bit too much to keep going in your brain. So at least for me. So maybe you can do it, but I don't try to do that. I try to do just one translation or reflection at a time and go from there. Okay, so let's see what else we got. So more of the square root. All right, so E, we have square root of -x. So that is reflect around the y-axis. And so instead of the original looking like that, we're going to come out this way. So we have, and we'll do a full one of this. So now the x coordinates from the original, so instead of 1, 1, we'd have -1, 1. Instead of 4, 2, we're going to have -4, 2, and so on. All right. Now, what about this one? So this one, let's see. How might we do this one? I might not even worry about the reflection on this one. But I guess we could do this one. I'll show you a different way. So this one's a little bit trickier at first. So we have, think of it, let's rewrite this. So a better way to think about this, -x plus 4. So what does that plus 4 do? The plus 4 moves us left. And then the negative here, same as this, it reflects around the y-axis. So reflect around the y-axis. So we move left 4. So that would put us, let's go down here. So left 4, that would put us like that. And then we're going to reflect around the y-axis. So then that would put us like that. So that should be like this one. And we can, let's see, 1, 2, 3, 4. That's going to be up 2, and then we'll kind of abbreviate it there, but something like that. Now, the other way to do this is you could find the domain of this, and then just see wherever you're starting in the domain is where, and then that's where the origin should be, which we'll call this the origin wherever it is, the starting point of this graph. So to find the domain of this, square roots have to be greater than or equal to 0. So you can only take the square root of a non-negative number. So now let's solve this. So we get -x is greater than or equal to -4. Divide by a negative, so you got to reflect or switch the inequality. So we get x is less than or equal to 4. And that's the domain of this. So here's 4. We're going to get all the x's less than that. So that matches. So that's a way to kind of check. This one's a little bit tricky. I would recommend writing it as negative x plus 4 and go from there. Again, do the horizontal shift first, do the reflection next. All right, so given the graph of y equals f of x, sketch the graph of y equals f of negative x. Okay, so we'll just sketch this one up here. And so now we're given 3 ordered pairs. And so what happens if we reflect around the x-axis? So basically this ordered pair is going to go over here. So what's going to change? The x-coordinate will switch signs. The y-coordinate will be the same. So instead of -4, -4, we're going to move that to 4, -4. We have -3, +3. The x-coordinate is going to change signs. The y-coordinate is going to stay the same. We have 2, 0. The x-coordinate is going to switch signs, and the y-coordinate is going to stay the same. Okay, so now we just plot these points and connect them in the same way that they're connected here, and we should end up with the same graph. So we have 4, -4. So 1, 2, 3, 4. 1, 2, 3, 4. So that'll be about right there. We have 3, 3. 2, 3, 3, 3. And then we have -2, 0. About right there. And so you can see this one's going off to the left. So this is going to go off to the right. Then we connect those 2 points like that. And then we connect those 2 points. We'll connect these two, and then this is just going to keep going in the same direction like that. Okay. So all we just took this one and reflected it around the y-axis, which is what the negative x does. Like there. Okay, that might be it. I didn't have a graph down there. Oh well, that's okay. All right, so again, learn these rules, and if you don't learn the rules, then learn how to figure them out, because they're very easy to figure out. It's not like driving the quadratic formula or something from scratch. It's fairly easy. So whatever you have, and if you have you want to graph negative square root of x plus 5 or something like that, then make a table. Start off with the parent function, which would be square root of x. Pick some x values, and the more you pick, the easier it is to pick out the pattern. And then plug in, well, -1 wouldn't work for that. And then go from there. So pick out good points. These are not good points for square root of x. You might want to do 4 and 9. But pick out good points, and then fill in this column, fill in that column, and then see how they've moved. And that will help you out. And you can kind of figure out what the translation should be. So, all right. If you have any questions, let me know.